Okay, Assalamualaikum and good day, sir. My name is Muhammad Haiqal bin Syafrizam. Match number is B0819106161. And my partner is Muhammad MUADDIB BAKHTIAR bin MUZAFAR. Match number is B0819103227. We from 3BEE, Section 1, Group 1. So this is lab report for Lab 3, PLC instruction. DIFU, DIFD, ILL, ILC, JUMP, JMP, JME. Okay, so we go for procedure part 4.1, which is DIFU and DIFD instruction. Basically untuk this instruction is to make the output lamp will light up if we press or we release. Okay, for number 1, we need to construct this ladder diagram and observe result on PLC output for 1.00 and 1.01. Okay, this ladder diagram, if we try to run, the output will not show any will not light up. Actually the output is light up, but this is like a momentary switch, so we cannot see the output light. So we need to add the latching circuit here. So if we press switch 1, when the DIFU is turned on, so DIFU is to 20.00 here, and 1.00 will turning on and will latching the circuit. So we'll continue to turning on. But after we release the switch 1, the circuit will go for DIFD, which is differentiate down. So when we release, the output for 1.01 here, 330.00 will continue light up. And here is the latching circuit. Okay, next for interlock instruction.
Okay, for interlock instruction 4.2, for first step, we run the simulation for according to the following step, and we have to observe all output in every step. Okay, first, at initial condition, the output lamp outside the interlock is turned on. So second step, we gonna turn on 0.01, 0.02, and 0.03. We take the node for the finding, and then turn all input back to initial condition. That means we turn back to the before condition. And then the output lamp at 1.00 and 1.01 cannot light up, but the output lamp at the 1.02 will light up. As for C or step 3, we turn on 0.00. After turning on 0.00, the output lamp at 1.01 will turn on because the switch is normally closed. And then we turn on 0.01, 0.02, and 0.03. The output lamp at 1.00 will turn on because it is normally open switch, and the other output lamp will turn off. And then we turn off 0.00 switch, and all the output lamp will turn off. We'll turn off the 0.01 and 0.02. The output lamp still turn off. Explain the function of interlock instruction. From our observation, we can assume that interlock instruction is for control the output inside the command interlock, and it can be used as control panel to monitor and control the desired output. And for 4.3, jump instruction. Construct the ladder diagram. We have to construct a ladder diagram referring to the given figure. So after that, after we run the simulation. as we can see, we have give the step, and we will observe all output in every step. For first step, at initial condition, the output lamp at 1.02 light up, and output lamp at 1.01 will skip, and lamp 1.00 is in off condition. We will turn on the 0.01, 0.02, and 0.03. We take the findings that we get and turn all input back to initial condition. Output lamp at after we turn on the 3 switches, we get that output lamp at 1.00 will skip turn on, while 1.01 and 1.02 will turn off. After that, we turn on the 0.00 switch, and output lamp at 1.00 will turn on, and the other is turn off. And next step, we turn on 0.01, 0.02, 0.03. All the output will be turned on. Then we turn off the 0.00. The output lamp still turn on. So after that, we turn off the 2 switches, that is 0.01 and 0.02. The output lamp at 1.00, 1.00 and 1.01 will turn off. Explain the difference between interlock and jump function. At our finding, we got that interlock and jump function, the interlock we use to control the output, and jump we use as self-hold. Okay. Alright. We go to 4.4.
Okay, so for 4.4 is exercise to steering the motor. Okay, what we need to do is we need to construct a ladder diagram, which is for the circuit is by the time we push the start button PB1, the motor is still in stop condition, but when we release the PB1, so the motor will start rotating. So the motor will rotating for 10 seconds and will automatically stop. But for PB2 stop button, which is we use for emergency stop button, when we push the PB2, the motor will immediately turning off. So we need to do the circuits for latching circuit by using keep or set reset instruction. So we decide to using keep instruction. Okay, so this is the result for exercise 4.4, and this is the simulation. Okay, so we try to run the simulation. Okay, this is input is for PB1 push button, and this is differentiate down. So when we release the PB1, the motor will turning on, will start rotating. So we try to turning on. So okay, when we turning on the PB1, the motor still not rotating, but when we release the PB1, the motor will start rotating, and the counter will start count for 10 seconds, and then after 10 seconds the motor will stop rotating. Okay, then we try to do for PB2 emergency stop button. So we try to run, release, and here we'll push, and the motor will start will immediately turning off. Okay, this is we use keep instruction so for the latching motor, and here for timer, after 10 seconds the timer will reset the keep instruction, so the motor will stop. Okay. I think that's all for this lab. Thank you.
Thank you.